Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in CSC in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about Regula Falsi method. So in Regula Falsi method, so there's initial guess should be, this method is going to require two initial guesses. So that should be x0 and x1, such that f of x0 and f of x1 has two opposite signs. So indicating that the root is going to be lies in between x0 and x1. Okay. So this Regula Falsi method is going to have some of the assumptions or initial guesses. So that may be x0 and x1 such that so f of x0 and f of x1 has two opposite signs indicating that the root is going to be lie in between x0 and x1. So linear interpolation. So this method is going to be calculate a new estimate x2 by using linear interpolation between x comma x0 and f of x0 and x1 and f of x1. So this new estimate should be lies on x-axis, that should be given by the equation. So x1 minus f of x1 into x1 minus x0 by f of x1 minus f of x1. So this is the estimation formula that one will have to be calculated. So in linear interpolation, this method is going to be calculated a new estimate that should be x2. So by using linear interpolation, so that means it should be lies in between x0 and f of x0 and x1 and f of x1. And normally this new estimate is going to be lies on x-axis, and that should be given by the formula is this one. And updating intervals, suppose f of x2 has the same sign as f of x0, and the root is going to be lies in between x2 and x1, such that the x1 is going to be updated to x2. Otherwise, the root is going to be lies in between x0 and x2, such that the x0 is going to be updated to x2. So if f of x2 has the same size, so x0, x1 is there and x2 is there, and if f of x2 has the same size as f of x0, and the root is going to be lying in between x2 and x1, that means the x1 is going to be updated to x2. Suppose otherwise the root is going to be lies in between x0 and x1, so that the x0 is going to be updated to x2. So this should be the interval updating process. And iterative process means, so the steps 2 and 3 are going to be repeated until the desired accuracy is going to be achieved or maximum number of iterations is to be reached. The step 2 and 3 are repeated until the desired accuracy is going to be achieved or a maximum number of iterations is reached. Convergence, that means this method convergence linearly, so which means that the number of corrected decimal places roughly doubles with each iteration. And the Regula Falsi issues is that, so it is going to be failed to converge if the function is going to have a flat slope near the root, or if the initial interval is poorly chosen. So the Regula Falsi is going to have these other issues. So that means it is going to be failed if the function is going to have a flat slope near the root, or if the initial interval is poorly chosen. So overall, this Regula Falsi should be a useful technique for finding the roots of the function. So when the bisection method is too slow, but it requires the initial guesses and may not always converge. Okay. So this Regula Falsi is going to be used for finding the roots of the function. So whenever the bisection method is too slow, but it requires carefully initial guesses and may not always converge. So the application is that, suppose if I want to find the root of this x into e for x equal to 1, so where the limit should be lies in between 0. Okay. So I'm going to find the root of this equation, that should be 1 whenever the limit is going to lie in between 0 and 1. So it should be one of the backtracking breathtaking iterative methods in finding the roots of the nonlinear equations. And here the approximate root is found to be formed by the use of the straight lines and slopes. And it is also noted as based on Bolzano's theorem for continuous functions. Okay, so it should be a breathtaking iterative method in finding the roots of the nonlinear equation, and the approximate root is going to be found by the use of these straight lines or slopes, and it should be also noted based on Bolzano's theorem for continuous function. So what is this Bolzano continuous theorem? So if a function f of x is continuous in interval and a comma b, and f of a and f of b less than 0, then c belongs to a comma b exists, which f of c equal to 0. So if x is a continuous function, so which is going to be lie in between a and b interval, such that f of a and f of b should be less than 0, then I can able to say c belongs to a comma b for which f of c equal to 0. So graphical example, suppose so I'm going to take x axis and f of x on y axis, and I'm going to calculate f of a1 and f of b1. So these two are the intervals, and if I'm going to join with a straight line, so I'm going to obtain b2, that should be f of b2, and if I'm going to join a straight line, then I'm going to get f of b3. So this should be the graphical representation of this Regula Falsi method. And when it comes to derivation of this Regula Falsi method, so delta y by delta x, that should be f of x, f of a minus 0 by a minus c, and f of b minus 0, that should be b minus c. Or otherwise I can able to consider as delta y by delta x as f of a minus f of b by a minus b, or I can able to write it as f of a minus 0 by a minus c. In other words, I can able to write it as, so f of a minus f of b by a minus b, and f of b minus 0 by b minus c. So these are the three different equations we are able to identify. So by using any of the three approaches, we have to be derive the Regula Falsi method by using equation 1. So since f of a minus 0 by a minus c equal to f of b minus 0 by b minus c. And so from this, I'm going to obtain the c value. So how can I able to obtain this c value now? So f of a by a minus c, that should be equal to f of b by b minus c. So by multiplying cross of this, that means f of a into b minus c is equal to f of b into a minus c. Then from that, so b into f of a and c into f of a. Expand this. So a into f of a and c into f of b. So after expanding this, so I'm going to write c into f of b. So I'm going to shift this side here. So c into f of b minus c into f of b is equal to a into f of b minus b comes to this side. So b into f of a. So where the c comes in one side, so I can able to write it as, by making c as common, so f of b minus f of a, then c equal to this one by this one. Okay, and this should be the final equation of this c, right? So what I'm writing here is, so f of a by a minus c is equal to f of b by b minus c is there. I'm going to cross multiply this. So f of a into b minus c is equal to f of b into a minus c. Multiplying this, b into f of a minus c into f of a, that should be equal to a into f of b minus c into f of b. Right? We're making the common term in c, so I'm going to get this equation. Okay, so after taking the c as common, so I'm going to get this equation. So this is a regular Falsi algorithm. So if f of a is less than 0, then the rule exists, otherwise the rule does not exist. So the iteration process is that, so let c is equal to this one. So if f of c is equal to 0, then automatically c is the root. And if f of a into f of c is less than 0, set b equal to c. That means c equal to b. Sorry, b equal to c. And else if set a equal to c. So this is the algorithm of a regular Falsi method. So in regular Falsi method, so first we have to be identified f of a and f of b. If the product is less than 0, then the rule exists, otherwise the rule does not exist. So whenever the iteration process exists, okay, so c equal to f of a into f of b minus b into f of a by f of b minus f of c. So if f of c equal to 0, then stock c is the root, and if f of a and f of c less than 0, then b equal to c, otherwise a equal to c. So go to beginning here again and repeat this entire process. And this application of regular Falsi. So let us consider an example. Find the root of this equation. So x into e power x is equal to 1 on x, L is equal to 0, 1 with the regular Falsi method. So considering f of x is equal to x into e power x minus 1 equal to 0. Okay, so considering f of x is equal to e power x into e power x minus 1 equal to 0, where a1 should be 0 and then b1 should be 1. Okay, so by substituting x equal to 0, so 0 into e power minus 0 minus 1, that should be minus 1. By substituting 1, so 1 into e power 1, so 1 e power value is this one. So find the product of f of 0 and f of 1. So minus 1 into 1.7183, that should be minus 1.7183, that should be less than 0. That means the c is going to be lies in between 0 and 1. So find out the c1 here. So a into f of b minus b into f of a by f of b minus f of a, this will be the equation. So by substituting these values here, so 0 into f of b and b into f of a, I'm going to get this one. Then f of c naught, that means, so I'm going to get this minus 0.468. That means the root is going to be lie in between here. Then choose a2 and b2. Okay, so after this should be a1 and b1 values. And now I'm going to choose a2 b2 values as this one and this one. So by substituting these values here, so I'm going to get 0.369 and choose a2 and then b2. I'm replacing this. Again continue the process. So a2 into f of b2 minus b2 into f of a2 and f of b2 minus f of a2. So I'm going to get this value, and f of c2 should be going to get this one. So again choose this. The root is going to lie in between a3 and b3, and again calculate c3 value by substituting the values here. I'm going to get this one, and finally I'm going to get f of c3 equal to this one. Again choose this one, choose a4 and b4, which is going to lie in between them, and then finally calculate the values of f of C here. So from the previous calculation, so f of a equal to 0 or a equal to 0 and b equal to 1, I'm going to get c values this one and f of c is this one. So after considering this 0.3699 and this one, the c value what I'm getting here is this one and f of c value is this. And again a value is this, b value is 1 and again this one and f of c is this one. So while doing all the calculations like this, see this, so 0.5671 and c value is also same and here also the same value I'm getting here and here also I'm getting the same value. So the approximate solution for the problem is 0.567. Okay, so like this we are going to be calculate the root of this nonlinear equation by using the Regula Falsi method. So Regula Falsi method. So Regula Falsi method initially is going to have initial guess. So where the method is going to require the two guesses that should be x0 and x1, such that f of x0 and f of x1. So which is going to have opposite signs and the root is going to lie in between x0 and x1. Okay. So by calculating this new estimation, so in it x2, so by using linear interpolation method, which is going to lie in between x0 and f of x0 and x1 and f of x1, the equation is going to be given by this. And for updating intervals, if f of x2 has the same sign as f of x0, then the root is going to lie in between x2 and x1. And in the iterative process, the step 2 and 3 is going to be repeated until the desired accuracy is going to be achieved. And the convergence, so the method convergence linearly, which means that the number of correct decimals roughly doubles the iteration. So overall, this Regula Falsi is useful technique finding the roots of the equivalent functions. So whenever the bisection method is too slow. So application is this: finding the root of this x into 4x minus equal to 1, where the interval is multiplying between them. And when it comes to this Regula Falsi introduction, so it should be one of the break-taking iterative methods in finding the roots of the nonlinear functions, and it also to be based on Bolzano's theorem for continuous functions. So what this Bolzano's theorem is that, so if the function f of x is continuous on the interval a comma b, then f of a and f of b should be less than 0, and where the value is going to lie between them for which f of x equal to 0. And this should be the graph. So x and f of x is going to be taken, and drawing this value in between f dash f of a and f of b1, I'm going to get the slope value, and f of b2, and again going to consider in between. And the derivation of Regula Falsi method, so these are the three different possible equations. So by considering any one of the three approaches, I'm going to find the c value here by substituting this one into a corresponding equation. So after finding the simple calculations of this, I'm going to get the approximate c values this one. So the algorithm is that, so if f of a and f of b should be less than 0, then the root exists, otherwise the root does not exist. So this iteration process where then the root exists is that, so c is equal to this, if f of c is equal to stop, then f of a and f of c less than 0, then set b equal to c, otherwise I have to set a equal to c. So according to this application of Regula Falsi, so I'm going to consider an equation this one, and by substituting the values f of 0 and f of 1, and I'm going to get this value. By product of this one should be less than 0, so that's why since I'm going to get minus 1.783, so that's why the root is going to lie in between 0 and 1 only. So by calculating the c1 initially, so I'm going to get this value, and again considering this and calculate the next f of c2 and then calculate f of c3. So by taking this, construct this table and then find out the values. So by observing this, So the A and B values continuously equal to C. So hence the C1 is continuous. That means so 0.761. So the value is fixed here. So that's why the roots of this equation should be 0.569. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.